Hello everybody, today we'll talk about impact hammer. An impact hammer or modal hammer is an instrument used for conducting experimental modal analysis on test structures. So these analyses are conducted on test structures to determine the natural frequencies and mode shapes. Unlike a regular hammer, an impact hammer is a load cell which records the force with which you're hitting. And during testing, the impact hammer is connected to the data acquisition system, usually via BNC cable, so that it can actually send those force data back to the data acquisition system, which can be used for further analysis. Now, there are different types of hammers based on different sizes. Now, it's important to use an appropriate size of impact hammer for the appropriate structure size. So if you're using a large structure, you need to use a proportionately larger impact hammer size so as to perform the experiment. So broadly classifying, there are three types. The first is a miniature impact hammer. As the name suggests, it's used to excite small structures, for example, PCB boards. And there is a standard impact hammer, which is used to excite medium structures, such as engine blocks, car chassis, etc. And there's a sledgehammer, which is used to excite large structures, such as pumps, compressors. Now, this is a typical hammer schematic. So first on the left, you see a hammer tip. So there are different types of hammer tip. This is the part that is actually coming in contact with a structure. And then there is a built-in force sensor within this hammer, and you have a rubber holder to hold it. And on the other end, you have this connection, which is usually a BNC or a micro dot, and it's going to the data acquisition system to send this input force data to the data acquisition system. So there are different types of tips, for example, rubber, plastic, and steel. Different tips permit the energy content of the force impulse to be tailored to suit the requirements of item under test. The duration of the contact time directly influences the frequency content of the force. A larger contact time results in a smaller range of bandwidth. On the other hand, a shorter contact time results in a longer range of bandwidth. For example, softer tips such as rubber tips stays longer in contact and hence result in a smaller bandwidth. And on the other hand, stiffer tips such as steel tips stay shorter in contact, hence result in a longer bandwidth. Now, when I say shorter in contact and longer in contact, they're just relative. A rubber tip still stays in contact way less than 1 second, but it's longer relative to a steel tip. Now, if you look at the force spectrum, this is the general trend. This is not the exact curve because there are different types of tips, but the trend is usually that rubber tip has a flat frequency response very close to 500 hertz. So this is because it stays longer in contact, hence it's going to reflect in the force spectrum that it's going to be shorter. It's going to have a shorter bandwidth. And this is better for plastic tip because the plastic tip stays lesser in contact relative to a rubber tip and hence has a wider bandwidth. And this is even the best for steel tip because it's more stiff and it stays a very short time. The contact time is very short, hence it's reflected here. The bandwidth is very large. Now, there is one important thing when you're performing this experiment. It's called modal tuning. It's important that the hammer itself doesn't influence the measurement of the test structure in any way. Like every other structures, each structure is going to have its own natural frequency, and this modal hammer is no exception. It's also going to have its own natural frequency. So this natural frequency should not lie in the frequency range of excitation. If it did, so when you hit and when that part is vibrating at a particular frequency, and it's going to excite the hammer to also start vibrating, and there will be resonance phenomenon, and then you will have erroneous results. So a modally tuned hammer is thus free from this resonance phenomenon in the frequency range of excitation. All right, thank you for watching the video. I hope you enjoyed it. Have a great day.